The integral from negative infinity to 0 is an improper integral. We have an infinite limit on our integral, lower limit specifically. X times e to the negative 3x dx. These two terms are a product of an algebraic term and an exponential term. We can integrate with integration by parts. Let u be your algebraic term. Its derivative is 1 dx. Let e to the negative 3x dx be your exponential term, and that's your dv. The antiderivative is negative 1/3 e to the negative 3x. I'm going to replace that lower negative infinity with an a, but we're going to have limit as a goes to negative infinity to help that out. U times v, it's negative 1/3 x e to the negative 3x, evaluated at 0 and a. We'll take the limit of that a part of it, plus, and the reason it's plus is we go minus integral of v du, minus negative 1/3. That's why I put a plus sign here, minus negative 1/3. v du is 1/3 e to the negative 3x. Substituting in 0, negative 1/3, I pulled it out. I'm sorry, I had to take a phone call. Substituting in 0, we have 0 times e to the negative 3 times 0, so that goes to 0, minus negative 1/3, which I've already pulled the negative out, but subtracting, you got to be careful. This value of a going in, a times e to the negative 3 times a, as a gets very small, this term gets very small as well. So that becomes in negative infinity. Well, that already qualifies it for divergent, but let's go to this back part. We have 1/3 times the antiderivative, which will be a negative 1/3 e to the negative 3x, multiplied with that 1/3 out front, is where I'm getting this negative 1/9. Evaluating at 0, that'll give us negative 1/9 times 1. That part goes to 1. And then minus a negative gives us a plus. And then we plug a in. E to the negative 3. This should be an a. I just goofed it when I wrote it. That should be a. Right there, negative 3a. As a goes to negative infinity, this value actually goes to positive infinity. So long story short, we don't end up with a finite value, so we have a divergent integral. The integral from 1 to infinity of natural log x over x dx, the top value is infinity, so I'm going to rewrite that with a b, and we'll take the limit as b goes to infinity. I'm going to let natural log of x be my substitution. Its derivative is 1 over x dx, which is the rest of the integral. Integrating u is 1/2 u squared plus c, where u was natural log x. So long story short, we get an antiderivative of 1/2 natural log x quantity squared. Substituting in a b and then a 1, factoring out the half, we have limit as b goes to infinity of natural log b squared. Well, the larger your natural log takes on back here, the larger the value is overall. So this term goes to infinity. Natural log of 1 is 0. 0 squared is still 0. So when you approach infinity, half of infinity is still infinity. So we have a divergent integral. The integral from 0 to 1 of 18 over x squared, we can factor out this 18. Actually, it's a scalar multiple, so we'll pull it out front. Integrating from 0 to 1. This fraction is not defined at 0, so it makes it improper. We replace 0 with an a, but we're going to let a approach 0 from the right. This fraction can be written as x to the negative 2. Add 1 to the power, divide by the result, and that gives us negative 1 over x. I'm going to pull this negative out front with the 18, and then we have 1 over 1 minus 1 over a, and that's the one that'll catch the limit. The smaller this denominator gets, the larger that fraction gets overall. So that's infinity, negative 18 times 1 minus infinity is infinite. So we have a divergent integral. This integral, we can use integration by parts. We have an algebraic term x squared times a logarithmic term ln x. Natural log ranks higher than algebraic in our LIATE form. I'm going to scroll this back down a little bit. Here we go. So I'm going to let u be natural log of x. Its derivative is 1 over x dx. The antiderivative I'm after will apply to x squared dx. That's my dv term. Its antiderivative is 1/3 x cubed. Since this function is not defined at 0, because natural log only likes to take on positive values, that's the one I'm replacing with a, but we'll let a approach 0 from the right. Breaking this integral down using integration by parts, we have uv, 1/3 x cubed ln x. We're going to evaluate it at 1 and a, minus the integral of v du, so minus 1/3 x cubed times 1 over x is x squared dx. In the first part of this problem, we're going to take 1/3 times 1 cubed times natural log of 1. That's with that top number plugged in. Well, ln of 1 is 0, so that first part goes to 0, minus 1/3 times a cubed ln of a cubed ln of a. As a approaches 0 from the right, this term will go to 0. Now in class we used our graphing calculator, and we also looked at, to just generate a graph, we also looked at a table of values, letting a approach 0 from the right with smaller and smaller numbers. We found that to go to 0 as well. Back here, our antiderivative is x cubed over 3. 1/3 times negative 1/3 is negative 1/9. Plugging in 1 and a, we have the limit as a approaches 0 from the right of 1 cubed minus a cubed. The smaller a gets, the more that last term approaches 0. So it'll approach 0, leaving us negative 1/9 times 1. Back to the front, we have 1/3 times 0 minus 1/9 times 1. And so overall we get negative 1/9, and that's a convergent integral.